Okie doke. You won't find Euler or Hamiltonian walks in the syllabus anymore. Okay, it was in there and it got taken out, but it's really handy if you can solve, if you have knowledge of at least Euler trails and circuits. So I'm going to teach you about Euler trails and circuits in this lesson. Okay, because it can be used to solve problems later on in networks. So an Euler trail, these are trails that start and finish at different vertices, where every edge of the graph can be traversed once. So I'm going to start here and I'm going to show you what I mean. I can go over every edge with my pink line once and exactly once. I go through the vertices more than once, that's fine, but every edge once. To have an Euler trail, you must have two odd vertices and all the rest must be even, and you must start and finish at an odd vertex. For an Euler circuit, these are circuits that start and finish at the same vertex, where you again go over every edge of the graph once and only once. So if I have a look at this network, every single one of these vertices is even. You could start absolutely anywhere and be able to get round that network once and once only on each edge. Okay, so for an Euler circuit to exist, all the vertices must be even. Right. So in the textbook, it's got these three examples. Decide if you can have an Euler trail or an Euler circuit. I've blown them up. So for the first one, I notice all of these vertices have two edges going into them, so they've all got degrees of 2, so they're all even, meaning I could start at any of those vertices and get round the graph without taking my pen off the page. Okay, so all the vertices are even, so I've got an Euler circuit. If I look at this graph, if I go, well, that's even, one odd, second odd, even, so I've got two odd and all the rest even, so that means I can have an Euler trail. I'll have to start and end at the odd vertices, and if you watch the green line, it's possible. Okay. Third example, there's 1, 2, 3, 4 odd vertices. I'm not even going to try and get a line going over every single edge once in that, because I know it's impossible. There are 4 odd vertices. So you cannot have an Euler trail nor an Euler circuit. Alright, so again, I know this isn't part of the syllabus anymore, but having that knowledge of what an Euler trail is or an Euler circuit will help you further on in this networks topic. So there are some questions to do on this exercise.